So we're talking about adding functions to other functions, and then we're talking about their domains. So a few things ahead of time. Domain. Do you remember if I had something like x squared, y, or f of x? Let's use f of x equals x squared. F of x is x squared. That one I cannot crash no matter what because it doesn't have a denominator that could be made 0, and it doesn't have a square root, so I can't crash that one. So the domain of this thing is all reals. That ring a bell? Remember that? Okay. And how about, I'll give you a simple one. The denominators aren't going to be like super hard today because the point is doing something else with them. On this problem, x could be anything at all. Like it can be 0, it can be negative 23, it can be 17. The one thing x cannot be is what? Negative 2. And so therefore it's all real numbers except negative 2. All real numbers except x cannot be negative 2. Another way to write that is on a number line. And I need to remind you, if you had a number line like this, that would be the way to write the domain for that. Does this make sense so far? Okay, good. What if we had another function called g of x? And g of x didn't have any restrictions on it. F, g. G of x has no restrictions, like it's just x plus 5. Is there any way to crash that? No. You can put in any number you want and it won't crash. So that one's domain is all real numbers. Okay? So if I made a square root on it, now is its domain all real numbers? No, because now we would set it up where we'd say x plus 5 has to be greater than or equal to what? 0. So then we'd say x is greater than or equal to negative 5. Okay, so its domain, if I make it a number line, looks like this. It has to be bigger than negative 5. Here's negative 5. Can it be negative 5? Yes, because if I put in negative 5 here, it makes it 0, but square root of 0 is not a problem. It doesn't crash, so it works. Or it has to be bigger than that. So now, do you get how I've got a black number line and a blue number line? Now here's the question. If I were going to take these two functions and add them together, f of x plus g of x, the hard part is not adding them together. You just take this is f of x plus this is g of x. You just add them. That plus that, done. It's adding them is the easy part. Hard part is what's their domain? All right, so it's like you've got this new function here that's the product of two things. It's not a product, it's sum in this case. But the point is it came from these two parent functions like this. Kind of like you came from your parents. Like you then hold all the weaknesses and strengths of your parents. My kids, my wife and I both are pretty good at math. Grew up good at math, and so our kids, all of them are good at math, just kind of like that was their thing. My wife has really bad eyesight, and so one of my kids ended up getting the really bad eyesight, but the other two got my eyes, which is good so far. As they get older, maybe like when I'm starting to notice, I'm in the mid-40s, there's a chance I might have to someday have correction for reading or something, but so far I'm good. My point is that they're a product of their parents. And so this function right here is going to have the same weaknesses as its parents did, kind of like a mix of the two. So you overlap this number line and this number line to find the domain of f of x plus g of x. So finding this is easy. You just take this plus this, done, easy. But that's not really in there anymore. But finding its domain, you take this and you overlap them. Let me show you what that looks like a little more closely. So if I have these two number lines, and here's negative 2, empty spot, and it worked everywhere else, right? I make the other number line, and I be careful where I put that 5, because I can't put it over here. That's not where 5 is. 5 would be like over here. And remember how it was x is bigger than 5? Or was it negative 5? Okay. Sorry about that. That's important. Thanks for telling me that. So negative 5, I really need to extend this number on. In this way then, and negative 5 will be over here. Negative 2 was like around here. 3, 4, 5. Here's negative 5. And it had to be bigger than negative 5. Is that what it said? Now here's the part where... Yeah, you're right. Hold on a second here. Not done yet. Okay, now have I got my two parent domains? This was f of x, and this was g of x. Have I got them both written correctly? Then what you got to do is figure out where do they overlap. And if you do this number line thing that I'm showing you, it works way easier than any other way that I know of. Okay? Do you get that they overlap from there over, as in from where to where? What's this block here? From -2 to infinity. Good. And does it work? Do they overlap at -2? No, because this one has -2 in it and this one does not, so they don't overlap at -2. So it can't be -2 and it can never get to infinity. So there's a part where they overlap, but do you see another part where they overlap? From 5 up until -2, they have both worked. So that would be from -5 to -2. Always do the two numbers on the end there first, and then you say, should I do brackets or parentheses? Well, one of these is a bracket, one of these is a parentheses. This one's a bracket because they both can work at -5. This one's a parenthesis because they don't both work at -2. And granted, one of them does, but the other one doesn't. So it's only where they overlap. Do you get how I just found where those two number lines overlapped? Okay. That's how you do today's homework. They're going to give you two functions. You're going to figure out the domain of the two functions. You're going to make a number line for both of them. You're going to see where they overlap. So the hard part is really reading the number lines. Let's do another one like this. Let's say I had, this is 3, and it doesn't work at 3. And let's say it works up until, let's say it there, which is, let's say, 8. And let's say it works at 8. So there's one of my domains. And let's say my other domain looks like this. And it works from 1 to infinity. Can you tell me the correct little set of brackets and parentheses union with each other that will give me the answer for where these guys overlap? Try it. Something, comma, something, to something, comma, something. So is there any little spot like right here where they overlap? No, they don't overlap at all in there. That doesn't work. So it's only from here to here then, isn't it? That they overlap. So it would be from 3 to 8 with a parentheses here and a bracket right there. Raise your hand if you had that one right. Okay, good. So then all you have to do is try to figure out what your function's domains are. Write the two domains like this. And that's why if you still don't understand domains now, you're stuck because you got to do domain to even start this problem. And you do the domain for the one function here, domain of the other function here, see where they overlap. Yes, ma'am. Places where they overlap?
No, there's like 3 different points that you have to look at in order for it to work, to get all 3 numbers. Or only 2.
Say it was like this. There's 3 important points on that one. Say it's empty there, filled in, empty there, filled in, closed there. Okay, say it was like that. That's 3 points. Is that kind of what you're talking about? Okay, and now let's say on the bottom it started at 0 and it went this way. Then you'd tell yourself, okay, it overlaps from here to here. Notice how that point doesn't really matter now because it's not overlapping there. And then it also overlaps from there to there. And it stops. So it would be from 0 to 2, where it works at 0 and it doesn't work at 2, union with, can you finish it? Got it. Okay. There's even one kind of problem where you have 3 number lines overlapping. It's the same idea. They all have to work. So for instance, let's say you had from 3 to infinity on this number line. Let's say this number line works from like 0 to 5. Doesn't work on the ends. Let's say on a third one, it worked from 4 to negative infinity. And if they all 3 have to overlap, I'll show you how what that kind of problem is in a second. Would you give it a shot here and tell me where you think they all three overlap? From what to what? On this whole zone here, they don't all three overlap, right? So that doesn't work. So it's really only starting right here where they all overlap and going up to here. So it's from 3 to 4. And does it work at 4? Yes. Does it work at 3? There you go, from 3 to 4. Make sense? Okay, that's just overlapping number lines. And the number lines come from the domains. So why would you ever have 3 number lines? Not because there's 3 functions. There's a bunch of things you can do with functions. You can add them, subtract them, multiply them, and divide them. Add, subtract, and multiply are all easy. If you have f of x and g of x, I'll keep it simple. One's x squared, and one's 1 over x. Okay, those are my 2 functions. Probably should write this a little more compact because it looks like that's all one big function. So g of x is that. Okay, got 2 functions. Now, adding them, subtracting them, and multiplying them, you just need to take your 2 number lines for them and overlap them. But on dividing them, that's the one kind that's more complicated. F times g is easy. F plus g is easy. F minus g is easy. And all of those problems, all you have to do is to overlap 2 number lines. It's f over g. Or the other one, of course, which would be what? G over f. Those are the 2 that have 3 number lines, and here's why. Would you agree that they only have 2 parents here? Each function only has 2 parents. But why is it important in a divide problem to think about what numbers won't work? We've added something new in there. Yeah, g. What about g in this case? What can't g be? 0. Do you get that before it was okay if g was 0? It was okay if this function had a 0 on top and came out to an answer of 0? But now we can't allow g to be 0. All right, I'm going to make this x over x plus 1 because the way I wrote it, that function could have never been 0 in the first place. Now this function for g, that could be 0 because I could have 0 on the top and then the bottom would become 0 plus 1 is a 1. So this function could be 0. But why wouldn't we want to let it be 0? Because if g was ever 0, then the whole thing's going to crash. So this one has 3 number lines. It has the domain of f, which is number line. It has the domain of g. It has to work in there too. And the third thing it is that g cannot be 0, is my third number line. And what would make g be 0? Look back up here. What would make g be 0? -1. So -1 is the one thing that it can't be. We can't let x be -1. So, wait. -1 would not make this thing 0. -1 would make the bottom 0. What would make the whole g function be 0? What would make this whole function become 0? Not crash. That's not what I said. What would make g of x be 0 if x is 0? If I put in a 0 right here, do you get how the answer would become 0 over 1, which equals 0? And why can't I let g be 0 this time? Because it's on the bottom. And a g can't be 0 because if it was, the whole thing would crash. So there's 3 number lines on the kind where you're dividing. And the third number line is that g can't be 0. So what would make it be 0 if x was equal to 0? So I have to pick that spot be 0, and I can't let it be 0, but it could be anything else. Next, what's the domain of g? All right. Looking at its original, how it looked in the original case, what's the domain of this thing? Domain of G. What numbers would work? Everything works except what? -1. There's the domain of G. And how about the domain of F? I'll do that in red. All reals. How do you make a number line for that? Like that. Number line that everything works. Okay, so I'm going to overlap those three. Domain of F was all reals. Domain of G was everything worked except -1. So here's a -1, and everything works except that. And my third number line again was that G can't be 0 because it's on the bottom. We can't let it be 0 then. So what would let it be 0? If this was a 0, that would make my problem. It would make G equal to 0. So I can't let it be 0. That's why this is the way it is. So now, where do all three of those overlap? This you should be able to handle. Tell me the final answer to this one. What you're finding is, where do these three number lines overlap? You're finding the domain of F over G. The domain of F over G is three things overlap. Try it. Don't just look at it. Write it on your iPad. Yes, ma'am. You can have a 0 on the top of a fraction, but you can't have it on the bottom. Okay, this is one problem at a time. I'm doing this problem right here. You're right, if we did this problem right here, then F wouldn't be able to be 0. That's a different problem, though. Okay? Not doing that one right now. We're just doing F over G. So where do they all overlap? There, they all overlap. That's from -infinity until it gets to -1. Good. And it doesn't work at -1. There we go. Union with, where's another spot they all work? Up to there. -1 to 0. And where's the third spot where they all work? 0 to infinity. Okay. I went right to the hardest kind of problem. So let's back off and just do an easy one now. Let's say we had to do F times G. Well, first of all, the first thing that you'll be asked to do on your worksheet is, what is F times G? Simple as that. No domain stuff. The domain's the hard part. What is F times G? Well, what's F? X squared times what's G? X over X plus 1. That, all you have to do is multiply that. And do you get that fractions only work well with other fractions, so I really have to change this to over 1? You get that? And now you know how to multiply fractions? I've been trying to drill you on the basic facts like this. You just multiply across the top, multiply across the bottom. So 1 times all that, bottom's just X plus 1. And what's on the top when I do X squared times X? X cubed. X cubed over X plus 1. So the multiplying them out, that's the easy part. You just multiply the two. Okay? Once I multiply those two out, I end up with X cubed over X plus 1. Now, what's the domain for it, though? That's these two number lines overlapped. This number line here and this number line here. These are the two domains of the parents. So it's going to have the weaknesses of the two parents combined. So I'm going to overlap those two number lines. Wish I had more room, but I don't. So I'll just go, domain of F is like this. Domain of G is like this. It only has one weakness at -1. And then you'd ask yourself, where do the two number lines overlap? From -infinity to -1. And then from 1 to, or -1 to infinity. Okay? Give me a 1, 2, 3, 4, 5. 5, I think I'm totally ready to do my homework. To 1, I am so lost you can't even imagine. Okay, good. I'm getting mostly 4s. So I think we should start your homework. I'll help you with it. We'll just do the first few together. Now, I want to warn you ahead of time, in case you forget this later. You do not yet know how to do 9, 10, 11, and 12. We were supposed to be doing the whole worksheet, but you cannot handle these bottom 4. But don't like scribble them out. We'll do them tomorrow together, but they're not assigned. Just do 1 through 8. Because we have a shortened class period, and there was no way I was going to try to go one more step where you'd have gone home totally lost, and I hate that. Good question. I will pull up the, and I'm done with the video for now.